Welcome back to video 11 of our series of covering the mathematical tools of the trade, so to speak, from Allen High School, AP Chemistry. Now, we were discussing using the ideal gas law to calculate a molar mass. And reality is we use more sophisticated equipment, but this is still, I think, a good way for you to realize some of the approaches that were used in the past, as well as some critical thinking approaches. Now, in this example, we're given a volume. So you want to circle the given, and you might as well check those units, and liters are just fine. We're given a mass, and grams is fine for mass in this case, because we're dealing with molar mass. Now, usually kilograms are our SI unit, but in this case, we're dealing with molar mass, which is grams per mole, so grams is good. Kilopascals is fine, that's our pressure. And remember, if you have kilopascals, R is therefore going to equal 8.314. As you can probably tell from these examples, I have a preference for kilopascals just because, you know, we're getting into SI units and it's a little more universal. Now, they also give us a temperature of 40.0 degrees Celsius, and Celsius is not okay, so we need to add 273. Since I went to the 10th here, I go ahead and add 273.15. That's not going to make or break your problem. I just like to be consistent. Now, in actuality, if you look at this number now, it has 4 sig figs because you round to the furthest to the left. So that has 4 sig figs. This has 3 sig figs. This actually has 2 sig figs, because without a decimal point there, that 0 is not significant, and this has 3 sig figs. So that will help us, you know, understand how many sig figs should be in our final problem. Now, it asks us to determine the molar mass. It doesn't say anything about density. It doesn't give us any, it doesn't ask for density. It doesn't give us a density. And so you have 2 choices. You can do PV is equal to nRT, and first solve for moles. And then secondly, you can substitute that into molar mass, and molar mass would equal 2.55 grams for however many moles you calculate from that first part. I tend to like to do all my math together, and so I'm going to use PV is equal to mass over molar mass. Go ahead and plug in that moles are equal to mass over molar mass, RT. Solve this for molar mass. I like to solve my literal equations. I think it seems to me to be a little bit less writing. Mass RT over PV. And if we plug all of our numbers in, 2.55, the R, 8.314. You've got to be very careful about R in these equations. Our temperature, there's no reason to round that. You want to carry digits till the very end. And then we round to sig figs at the very end of the process. 170 over our liters. And if we solve that, do all that little algebra there, you should get a molar mass of 78, actually 78.11, but I'm just going to call it 78 grams per mole, so that we have our 2 sig figs. Now, if I were you, I would go ahead and pause the video at this point and work on the next one. You do at 16. The answer to you do at 16 is 30.03 grams per mole. And you might want to give that a try before I work it, because it'll really check for understanding. So give that a pause if you want to do that. I'm going to go on and work. You do at 16. I have an air sample. It has nitrogen. Don't forget about your diatomics. Nitrogen's N2, oxygen's O2. And this time it gives me a density and asks for a weighted average molar mass. So I'm going to be using meow meow. I see that density either asked for or given, and I'm going to jump right to my meow meow. And remember that that means that cats put dirt, DRT, over their pee. So that's a way to remember that. And so let's take a look. We're getting a weighted average. In other words, what's a weighted average of the nitrogen and oxygen components? So we're not getting each of those individually here. So we are given density, so 1.3393. Now, what do I do about R? Well, I don't have a pressure, I don't have a temperature, but what it does give me is the information that I'm at STP. And remember, if you are at STP, that means pressure, I'd use 1 atmosphere. It'll simplify your math quite a bit. And that means your temperature, pressure is 1 atmosphere, temperature is 273 or 273.15 Kelvin. That's 0 degrees Celsius. Drudges way back into pre-AP there. And that tells us that our R value has to be 0.0821. And if I plug all those values in here, I'm going to redo it down here so we can see it a little bit better. 1.3393 times R times T. Do not forget, if this was multiple choice, I promise you one of the answers would be what you would have been able to calculate mathematically if you'd forgotten to convert Celsius to Kelvin. And of course, if we use atmospheres, which is one of the advantages of atmospheres, that would be a 1. And I've got 5 sig figs in my problem. And so I'm going to go ahead and I'm going to call that 30.03. Honestly, I didn't have this to 3. I had 4. I had it to 4, not to 5. So I'm just going to put a 0 there. You make it something slightly different. Grams per mole. All right, now that's the end of using the ideal gas law to calculate our molar mass. And next we'll move into colligative properties, and then we'll be done with mathematical tools of the trade.